Okay, I'll go ahead and get started. Welcome, everybody. Today, we're going to talk about bringing Model Context Protocol to the enterprise. Just to give you a quick bit about myself, my name is Craig Jellick. I'm the Director of Engineering at Acorn Labs. You can see my socials up on the screen there. Bit of my background. Acorn Labs is focused on bringing AI to the enterprise, focusing primarily on Model Context Protocol, but also just all the tools you need to enable your enterprise to leverage AI. Before working here, I worked at Rancher Labs, where we focused on bringing Kubernetes to the enterprise. So spent a lot of my career just working through enabling enterprises with the latest, most important technologies. Today, we're going to really start with an introduction to the Model Context Protocol. I'll give you a quick demo of sort of how it works. Then we'll jump through some enterprise considerations, security concerns, architecture for addressing those considerations and concerns, and then we'll see a demo again. And fair warning, a lot of my demos will be using, both my demos will be using our open source platform, which is called Obot, O-B-O-T. And really, it's, a lot of these problems and solutions apply to many different products. Using this one, it's the one I'm most familiar with, but, hopefully the patterns and problems that I call out here can be used no matter what you decide as your solution. So with that, we'll jump in and we'll just start with a definition of Model Context Protocol. And this is from the protocol's website. It's an open source protocol that standardizes how applications provide context to LLMs. The analogy that a lot of folks seem to be drawing is it's kind of like the USB-C port for AI applications. It's a standard way to connect AI models to different data sources and tools. So really, it's about sort of taking the power of LLMs and just hooking it up to the tools that you use on a day-to-day basis. Why it matters now, it's really exploded in popularity sort of end of last year and really took off this year, throughout this year, and just continues to have crazy growth. And a lot of that is just it being an open standard and the developer community really latching onto it, adopting it, and finding new and creative ways to leverage it. So the entire standard is community driven. Anyone can submit, suggestions to improve the protocol. Those go through a refinement process, and eventually new versions of the protocol will be released that incorporate, the new suggestions from the community. Just recently, more well-developed governance standards have been introduced. So we're really seeing things mature around the protocol pretty quickly. Once again, as I mentioned, it's also important because it provides that universal connectivity. No matter what application you have on the backend, service, data source, you can use this single protocol to kind of bridge the gap between your LLMs and those services. It really makes it simple to use. In fact, there's half a dozen SDKs at this point for various programming languages. So writing an MCP server is pretty straightforward to get going. And then finally, like I said, there's just so much adoption in the community. You see sort of an explosion of MCP servers for all kinds of different use cases. So some of the fundamental features are here on the screen. I want to talk through those now. They're broken out this way for a reason. Really, this is different levels of adoption or popularity amongst the features. Far and away, tools and tool calling is the #1 feature of Model Context Protocol. If you look at most MCP servers, this is really the only feature they implement. Then sort of the next tier down, you have resources and prompts. These are useful, but not quite as popular. And then finally, some sampling, roots, and elicitation are very useful features, but again, just even less adoption of these in MCP servers, and they cater to more niche use cases. So just to talk through these in a little more detail, tool calling is the bread and butter of MCP, and that really is, hey, LLM, I want you to do this thing. Here's a set of tools you have available to accomplish that. Tell me what tools to call. We'll go off, we'll call those tools, we'll give you the response, and we can move on. Resources are very useful because they allow the user and the LLM to kind of share, more static context. So for example, very simple example, maybe you have a MCP that drives the browser, and there's several very popular ones there. And one thing such an MCP might do is take a screenshot of the page it landed on and provide that screenshot as a resource. So now the user can download that screenshot, or it could send it, or we can send it to the LLM, and the LLM can use, image recognition to pull things out of that screenshot. So resources just are a way to kind of share those, assets between the client, the LLM, and the MCP server itself. Prompts are really useful because those are sort of starter messages to help the user understand what the MCP server can do. So, that's just, you might see a list of basically, select from a list, a drop-down list of different things that the MCP server wants to let you know it's capable of doing. And it's like, instead of typing that out, I click it, and that's sent to the LLM. And it's just kind of like helper discovery mechanism for what you can do with this server. Sampling is interesting. The name is kind of odd, but the best way to describe it is sometimes an MCP server will want to do a little bit of AI itself. It will want to call the LLM to get some help with what it's doing. This is kind of like making that possible. So with sampling, the MCP server will say, hey, MCP client, can you send this to the LLM for me and give me the response? So it's just a way to like get a little sampling out of the LLM and back to the server. Routes are, again, I think this is probably the least used feature in my opinion, but for local clients, a route might say only work in this directory. That's kind of the easiest way you can think of routes is for this MCP server, just focus on using this directory. Elicitations is a newer feature. It was just added in the last iteration of the spec. Excuse me. And the point of elicitation is essentially the MCP server asking the user for more information. So it can very explicitly, when I send a request to MCP server can send an elicitation back, and it won't do anything until I answer that elicitation. So those get into the weeds a little bit. We're primarily going to focus on tool calling in this talk, as it's, again, the most used feature. And it's really one that I think we should focus on the most because it's really where you get the most mileage. And many of these other features are in support of tool calling in MCP. Okay. Next, I just wanted to give you a very high-level overview of the architecture of MCP, Model Context Protocol. And here you've heard me make reference to clients. We have different clients like Claude, IDEs such as VS Code, or really other chat applications as well. And those can connect to various MCP servers. And these MCP servers, that presents a standard interface. That's sort of where the protocol really pays for itself, as the client only needs to talk this protocol, the server only needs to talk the protocol. And then whatever is happening on the back end can be specific to the data source or the service. And the other thing you'll notice here is your computer versus remote. So if you're running a local client, you can have MCP servers just running locally. It's kind of like installing a Chrome extension to a certain extent. And those things just run locally. They can talk to local resources on your computer. They can also reach out to web resources. They can even go as far as interacting with your local computer, driving different applications. Just whatever the MCP server, author wants to implement, kind of the world's their oyster as far as how far they want to take it and the different interactions they have. And same thing with the internet. We can talk to applications, services, static websites, all of those things are possible. And we can mix and match these. The clients can enable and disable different MCP servers based on their use case. So some popular clients here, I just wanted to call these out if you're kind of getting started and you're not sure where to start. One place we're seeing a lot of MCP adoption is in IDEs, which are what software developers use to write code. So VS Code has been really at the forefront of adopting the latest version of the Model Context Protocol. But really, most modern AI-enabled IDEs or coding agents are pretty rapidly adopting the protocol. Outside of sort of that very programmer-specific use case, you have generic chat clients that also are adopting the protocol. I should have mentioned this earlier. MCP came out of Anthropic, who created Claude. So this is really seeing the most adoption from Anthropic and Claude because that's sort of a vested interest they have in making it successful and seeing the protocol be successful. So really across all of Anthropic products, you'll see heavy adoption of MCP. But yeah, with Claude Desktop, that's kind of what it sounds like. It's a desktop client you install, and it's a chat application. You just go into it, you can start chatting. It hooks up to the Claude models, and then you can choose to install various local or remote connectors there, which are MCP servers. ChatGPT also actually has MCP integration. It's actually, I'll say, lightweight or very tailored to the use case they want to support. So in my experience, you can't just plug any MCP into ChatGPT currently. What you can do is you can kind of implement the specific API that ChatGPT expects for MCP to create a new searchable data source. So you can't do arbitrary tool calling, but you can use it as part of deep research to do very specific sort of searching over new data sources. And that's the current integration ChatGPT has. Finally, I'll throw out Goose. It's an open source chat client. So again, it's another one you install locally. And it gives you that chat experience where you're just going in very similar to ChatGPT, starting a thread and chatting, but you can integrate with MCP servers as you want there. What's nice about Goose is it's agnostic. It's not owned by any of these major AI players. So you can plug in any model you want to it, as well as any MCP server. It's really wide open. So it's a nice option if you're looking for something open source. Okay. Moving on from here, I'm going to go ahead and show a demo of MCP server in action. And I actually need to share a different screen for this. So, okay, I guess I'm going to stick with this. I can't see. I wanted to share my Firefox browser, but I don't see it as one of the options. Maybe I didn't enable sharing in Firefox, but that's okay. We can kind of pivot to just sharing from this screen. Cool. So I'll cancel this, and we will jump over here. And what I'm going to do, so this is what I'm going to be demoing is our open source platform called Obot, but I want to start. The screen you saw before was an admin user, and I want to start as just a non-admin user here. So let's go here. Let's do this, and we'll do this one. I'm sorry. I wanted to share yet a different one. And there we go. Okay, and that was because I was on the admin page last. So here we are. Okay, and I see a question came in. How do you handle access control and permissions when exposing internet tools and APIs through an MCP catalog? And I'm actually going to cover that in the second half. That's really, the second half will be all about the enterprise concerns around using MCP servers. So I'll show that. I'll talk about that then. Okay, so let's just jump over to our chat screen here, and this should look pretty familiar to any folks using, either Claude or ChatGPT. This is just our version of chat application. But what we'll start with is just right out of the gate is adding an MCP server here. So I'm going to add this one. It's called Tavily. So Tavily is an API for basically doing web search and crawling and such. And I just added that so you can see it's a server here. And if I click tools, we can see the tools that are available. Here we go. So we see we have crawl, we have the ability to crawl a website, we have the ability to extract data from a website. You can map out an entire website, or you could just do a traditional web search. So let's see here if I had another screen open. Looks like I closed that one. I was going to basically scrape the the page for this conference and see who the speakers were, but I think I closed that tab. So let's just start with something simpler, and we'll say, let's look at those tools again. Yeah, we'll say, can you crawl acorn.io, which is our company's website here. So you can see here, the first thing that just happened was I said, can you crawl this website? That went to the LLM. The LLM kind of inspected what tools do I have available to me, and it saw there was a pretty good match with this crawl option. And so it went ahead and it called Tavily's crawl tool. In real time here, we're getting, content from that. And one interesting thing we can do is getting in the weeds a little bit. You can see sort of the inputs and outputs. So the inputs sent to this tool call were the URL, max depth, limits, and some other parameters there. And then we could see the raw output as well. But what's important is this raw output is returned from the MCP server and then sent to the LLM so the LLM can interpret it. So it interpreted and then kind of gave me a, an overview of what it saw on this website. Sorry, I just saw there was one person saying this is hard to read. I'm on a relatively big monitor. So hopefully that's better, and I'll try and do a good job of keeping this larger. This might throw off the zooming in, might throw off the overall scale, but we'll just tackle that as we go. So super simple. That was just the very basics of doing a tool call. Again, if we see, this is kind of all the tools presented by this MCP server, and we can go as far as seeing the different parameters available. And yeah, that's kind of an overall view of tool calling. If I click another add MCP server, again, these are just some that we've put into, frankly, what is our our shared testing environment. But the community is building thousands and thousands of MCP servers. Frankly, not all of them are great. So some of them, don't work well, or they just address a very specific use case. But the other thing we're seeing is companies, SaaSes, services are all starting to develop and expose their own MCP servers. And those are really where you're going to see the high quality ones, because that's the tailored experience they want you to have. So jumping back over to presentation, let's jump back in here. Let's just a super quick give you an idea of what it looks like to integrate with an MCP server. I saw a few other questions come in. I'm going to mark off the one about the screen, answer that. And then another one that sort of is talking about sort of some of the enterprise concerns. How do teams manage and maintain MCPs over time? Are there best practices for versioning, documentation, and discoverability? And yeah, that's again sort of one of the main concerns you want to have when bringing this to the enterprise. So let's just talk through those now. The bringing MCP to the enterprise, some of the opportunities you have is that super powered AI chat experience, which is essentially what I just showed. If you put a good LLM and a good set of tools in front of a motivated user, they're going to find a lot of things to do with it. Everything from just simple automation of tasks that they do repetitively to more deep discovery or research and analysis. That's all possible when you bring together MCP, LLMs, and motivated users. And really, as we've worked through this problem for a while, what we've seen is this really resonates with folks in any type of sort of like ops role, marketing ops, sales ops, DevOps, all of those like folks who need to be power users and need to get a lot done. Find very creative ways to leverage this. The second one, once you're past sort of just that day-to-day chat experience, you can really start writing powerful automations. You see a lot of AI-powered automation platforms out there, and even the more traditional ones that pre-existed, workflow automating tools like N8N. Even those are, reaching into the MCP space and integrating with MCPs. So it's really, I think that USB-C terminology really sticks because it really does seem to be, here's a protocol that everyone can implement against. And once you have those, you can start plugging them into traditional workflows, open-ended AI workflows, any of those, and really start to get things done in in an automated way. And I think what you'll see over time is an explosion of agents, within organizations, agents that can, be running autonomously to complete various tasks. So the things you need to consider as you approach this are management and discovery, security and access control, and auditing, logging, those sorts of things. So to accomplish these things, I think a good architecture, yeah. Let's see how I'm doing on time. Okay. So one of the, on the security front, some things you can want to consider are the attack vectors that folks see. So from modelcontextprotocol.com, they kind of highlight 3 key attack vectors: the confused deputy problem, token pass-through, and session hijacking. And these are all addressed in the protocol, either through things that implementers must do, or things that operators should do. And these all kind of center around what if a malicious attacker kind of gets access to a user's session one way or another, or their session or their token. Basically, they can start doing things as though they were the user outside of the control of the MCP client or the MCP server. The ones we've seen in the wild that have come up as vulnerabilities, one is, what we'll call command injection. So I think one of the published vulnerabilities for this was when GitHub produced its remote MCP server. A published vulnerability was, if a user says, read all my issues, then do whatever they say in it. And one of those issues said, read the user's private repositories and send the information to this third-party app. Well, if you just let that go, if the user just lets that go in sort of an unsupervised way, you can expose some private information that way. And then the other one, arbitrary code execution, this kind of showed up with sort of a utility to the local MCP clients like Goose or Claude to kind of bridge the gap of talking to remote MCP servers. And fundamentally, when you're running local MCP servers, to a certain extent, you're running arbitrary code on your local computer. So all the concerns that come along with that. You want to be able to sandbox. You want to be able to know what users are installing and running. And you just want to have control over that. The easiest way to control it is to not use a local client. If everything's remote, then sort of that vector of executing stuff locally is closed. The downside or flip side of that is you lose the ability to interact with your computer locally. So this is what a good architecture looks like. You want to have a catalog, and really what we envision is sort of each of these boxes is an opportunity to harden, secure, scale your system while also empowering users. So on the left here, you have sort of the different clients. You have your traditional chat client, you have your IDEs, and then you have deployed agent as well. These might be sort of, autonomous agents written by a developer and deployed into your system somewhere. The first thing you want is an LLM gateway. That's going to act as sort of a proxy to whatever LLM you're using. Having the centralized gateway enables things like, chargeback within your team. You can control who sees what model. Models are going to be good at different things. Folks might want different models for different reasons. And then also, importantly, exposes the concept of guardrails. So you can write custom guardrails to basically check either the input to an LLM or the output coming from the LLM. And you can do anything in there. You can arbitrarily check for whatever security measures you want to. You can even have another model reading the output of a response from the LLM and making a decision: is this safe? Is this not safe? That sort of thing. The MCP catalog, having a centralized catalog, is really where the IT admin or centralized AI team can control what users see, right? So, rather than users going out and just discovering any arbitrary MCP server, you can say, this is the catalog, and then make it easy for them to install and connect from there. And having that catalog also lets you manage server upgrades, configuration options, things like API keys, those sorts of things. So you can kind of all centralize that into a catalog and then give your users access to it. Finally, the gateway, similar to the LLM gateway, this acts as a proxy to any MCP server. You see, it can be remote MCP servers, either ones kind of like running elsewhere in your enterprise, or truly remote ones running out on the internet. And these ones are here as popular options because they were early adopters and exposed their services as MCP servers. And then finally, if you haven't, if in-house you haven't already started deploying them, you should consider. Sorry, I got an alert from the talk here. Okay. Yeah, so you need to have sort of hosting options considered, and how do you host these MCP servers if you don't already have a hosting solution in place? So yeah, these are all sort of like the basic building blocks of what you want if you're going to basically deploy MCPs within your enterprise. And actually, see, I'm getting close on time here. I'm going to quickly check the Q&A, and then maybe I'll jump over quickly on 1 or 2 more minutes just to show some of these features. So starting from the top, how do you handle access control and permissions when exposing internal tools? Yeah, this is really where a gateway comes into play here. So you want the centralized gateway, and then this gateway can implement whatever access controls you want. So the idea is, you can hook this up to your existing authentication provider and kind of use the groups configuration in your auth provider to say this group has access to this MCP server and enforce that at the gateway level. And then the MCP itself is going to talk to a downstream service, and that should be handled sort of the standard or suggested way to handle that is through OAuth. So you kind of, at that point, want your MCP server to act as an OAuth client, talking to the remote service, and it should sort of trigger an out-of-band OAuth workflow so that the user says, yes, I'm giving this server access to this remote service. How do teams manage and maintain MCP servers over time? I think this is one of the trickiest problems, and there's a lot of different ways to slice it. At the end of the day, MCPs, I like to think them as microservices, and we've been figuring out how to deploy and manage and upgrade microservices for a long time now in the industry. And it comes down to sort of all of those, DevOps best practices. Use GitOps to control the configuration and deployment of these services. And then, that next level is get them into the catalogs. And that's kind of the key way to expose them and, manage upgrades so that they don't impact users in a negative way, that sort of thing. This also handles discoverability. So you want this catalog to basically be tailored, again, using access control to exactly what the user is allowed to see and allowed to deploy. The next question here for prompt templating and user experience, designing prompts for non-technical users, what patterns have proven most effective for balancing guidance with flexibility? That's a great question. It's super tailored to, I think, the use case and the tools being exposed. So what works for one MCP server and one set of tools might not work for the other, for others. I'll also say, this kind of gets beyond simple throw some tools at chat and into what we think at our company is sort of the next generation, which is writing custom or tailored agents that kind of have a much more opinionated view of the world. They have sort of a stronger system prompt tailored to their tools specifically, and really kind of locks it down. So we see, I think Manus, which is sort of a super agent platform, came out recently with sort of their learnings from implementing a super agent. And a lot of it, there's a lot of great lessons to be learned there, but really sort of some of the key takeaways were, yeah, just throwing a bunch of tools at the LLM is going to have mixed results. You really want to build those sort of tailored experiences where you craft a system prompt and you have very specific tools and sort of this agent is good at accomplishing this specific thing. And then you can start to build up a system of agents where you can do handoff based on the user's intent. And that can either be explicit, the user, you kind of see this in ChatGPT where you can switch between different custom GPTs or, even their own built-in agents like Sora. So you can build up a system of agents, and based on the user's intent, you can kind of hand the user off to different agents, either explicitly or implicitly based on the chat. And then finally, the last question I see here in the demo with the Tavily MCP server, Tavily crawl tool, crawl Acorn.io and return a structured summary. How is the summarization capability implemented? Does it rely entirely on the LLM? Or are there additional heuristics? That's kind of an implementation detail of how Tavily works. I've looked at this in the past. I believe they are doing sort of a like an AI. They're processing the raw data and using AI to turn it into this summary that you saw. And Tavily specifically has a lot of knobs that you can turn and change its behavior. That was just one super quick example. Yeah, I see I'm a few minutes over. I do want to just jump into the demo one more time, show you how some of these concepts around the enterprise size come together, at least in our application. And as you're evaluating solutions, you can have sort of a reference point. So I'm going to come back here, pull this over. Bear with me for a second while I log out and log in as a different user. Okay, so this is sort of the admin view of our application, and you can see sort of like a lot of the major features we talked about are exposed over here. So this is the admin view of the catalog. And if we just look at that, let's go down to that Tavily one here. You can see this is what our configuration looks like. We have that description we're seeing, some of the basic stuff, but then here's the launch command for it. So here's what's actually happening when we launch that server. And then Tavily is a remote API. You need an API key. This we didn't write this Tavily server, so this is coming from the internet, and it expects this Tavily API key. And so what we didn't want every single user to have to enter a Tavily API key. So that's how you want to kind of use a centralized deployment mechanism. Okay, this is a shared MCP server. So the admin will go ahead and put in the configuration once, and then everyone will use that shared server. Other servers are very much intended to be used single user. They're not intended to be shared amongst users. So in that case, like, the admin wouldn't put in the configuration. The admin would only put in enough configuration so that when the user goes to enable it, they're prompted. So for example, let's look at Atlassian. Again, this is sort of like a community one. It has a lot more going on in it, but you can see basically this is a really rough one. It's just using it. There's Atlassian has since kind of made this experience better. This is an open source one, but you can see if the user were to launch this, they would be prompted for their instance URL, their username. So you can kind of put in all this information that is specific to the user trying to launch the server. Audit logs. I think audit logs are sort of, one of the most important things to think about. And we can see here, but I just filtered down to tool calls, and we can see sort of all the tool calls that have been coming into this instance through the gateway. So this is like every single MCP tool call we make goes through this gateway, and then you can come and kind of see the details of it. And you can do all kinds of cool things with this. So we can, we can see that raw response here. You can use this for just, after the fact incident investigation. You can use this data to, build out your filters. So these filters are sort of webhooks, arbitrary webhooks that you can add. And a webhook, we know, is just a way to kind of like, based on some event, do some random thing. The idea with filters is, when the Tavily crawl, when the Tavily crawl tool is call this webhook, and the webhook will make sure, no explicit content is coming back as a result of that. So filters are really sort of an arbitrary way to put injection points around MCP servers to control what they're doing. This is our solution for access control. So just the basic idea is you can combine sort of whatever groups you want, and then specifically, what MCP servers do those people in those groups have access to, either through the catalog as well as through the gateway. So here you can see adding the various ones. Those are major features I wanted to kind of show off. Chat configuration is just that initial chat experience we saw. This is where I can set my instructions on exactly how it should behave. This is the little welcome message we see. And then this is sort of allowing various models, OpenAI, whatever model providers you have configured, or sort of the different models that a user would be allowed to choose from. So I'm now 8 minutes over time. See if any other questions have come in, but otherwise, I think that's going to wrap it up.